there is a factory of light bulbs. That bulbs we have, light bulb factory. Two factories are there, factory X and Y. So the condition is that bulb, the standard for a good bulb is that it should give a service of 5,000 hours. Okay, it should give a life of 5,000 hours. So that is considered a good bulb. So factory X bulb produced by factory X, 99% of the bulb they give a life of 5,000 hours or more. 1% may fail, maybe less than 5,000. There is a factory Y for which 95% of the bulbs give life of 95,000 hours or more. So factory X bulb 99% and factory Y 95%. So factory X bulbs are more reliable, we can say, right? Now there is a market. In the market, there are only two players, factory X and Y. So suppose in problem it is given that factory X gives 60% of the market, 60% market share belongs to factory X, and 40% market share belongs to factory Y. Okay. So now the question asked is, what is the problem? What is the chance that a randomly purchased bulb, any bulb I purchase, I don't know which factory it belongs to. I randomly purchased one bulb. And the question is, what is the chance that a randomly purchased bulb will work for longer than 5,000 hours? Okay, so that is the question. Is the question understood by everyone? Question understood?
Yes, sir.
Okay, so now my question is, like 60% bulbs are supplied by factory X and 40% bulbs are supplied by factory Y. Simple question, I pick up a bulb from the market. Nothing is written whether it is factory X or Y. All bulbs look alike. I purchase one bulb. What is the chance of whatever bulb I'm getting? What is the chance that it is from factory X? What is the chance? For 60% are from factory X, 40% are from factory Y. Okay. So now I'm asking you, I pick up a random bulb from the market. No, we don't know whether it is factory X or factory Y. So my simple question is, what is the chance that this bulb will belong to factory X? Right? So 60%, right? So I don't know why you are confused so much. So 60% bulb, so 6 by 10 or 0.6. There is 0.6 probability that this bulb will belong to factory X. And if I ask you same question about factory Y, what is the probability that it will belong to factory Y? So it is 0.4, right? Because 40% bulbs are from factory Y. Okay, so now we got the simple question. Now, we don't know whether bulb is from factory X or Y. So factory X, 99% probability, and factory Y, 95% of the probability. Okay, so what is there? 0.6 into 0.99. I multiply, like I want to find out if bulb is from factory X, I want to find out what is the probability of it giving a service of more than 5,000 hours. So bulb is from factory X, so probability is 0.6. So 0.6 into 0.9, 0.99. Why 0.99? Because 0.9 is the probability of is the reliability of bulbs from factory X. Similarly, for factory Y, a bulb is there from factory Y, that probability is 0.4 because 40% bulbs are supplied by factory Y. So 40%, okay. So 40% bulbs are supplied by factory Y. So 0.4 is the probability that any bulb will belong to factory Y. And what should be probability that if it belongs to Y, what is the probability that it will run beyond 5,000 hours? So that is 95% because reliability for factory Y is 95%. Okay. So now if I add up both the probabilities, I get all the spectrum, right? So try to understand, like, first, what is 99 by 100? 99 by 100 is nothing but 0.99 is the reliability of factory X. So what is the chance of bulb getting from factory X? 6 by 10. 6 by 10 means 0.6. Similarly for factory Y, 4 by 10 is the chance that we are getting a bulb from factory Y. And what is the reliability? 95%, 0.95. So if I multiply and add up both, because a bulb can be there from factory X or factory Y. There are only two possibilities, right? Either factory X or at factory Y. So union will be there. Plus side. That's what we had discussed yesterday. So 6 by 10 into 99.99 and 4 by 10 into 0.95. So that is your answer, 970.974. So is this understood, everybody?
Yes, sir.
Yes, sir.
Sony, is this understood?
Yes, yes.
You understood? Can we get a bit quick background for you, your side? Quick introduction for your side.
Yeah, so currently I'm working in Oran Innovation as a senior software engineer.
Which company?
Orion Innovation, working for KPMG.
Okay.
Yeah.
And what is your education background? BTech.
B
B
in
in
computer
computers.
engineering. Yes.
From which college?
Viva Virar.
Virar, huh? Mumbai.
Yes.
Okay.
Yes.
So this problem is understood, right? The bulb
Mm-hmm.
can be there either from factory X or factory Y. So we have analyzed both. And we have to see, or it can be from factory X or factory Y. So if it is from factory X, what is the probability that it will give a service of 5,000 hours? First of all, factory X probability is 0.6. And the probability that it will give 5,000 hours is 0.9. So we got factory X data. Factory Y, probability is 0.4. That bulb belongs to factory Y is 0.4. And what is the probability that it will give, bulb belongs to factory Y, what is the probability that it will give life more than 5,000? Now, 5,000 hours. So that is 95%. So we add up, because there is a or, factory X or a factory Y, we add up both probabilities. So we get 0.974. There is a 0.974 per 97.4% probability that a random bulb which you purchase from the market will give a life of more than 5,000 hours. Okay. So it's a simple problem. You can have a look at later. I have anyway shared the, I have shared the PPT with you. So like this we have discussed, like probability mass function yesterday. So like I am asking a simple question to Sony. Sony, are you aware about these two graph, frequency graph and probability graph? Does they look sound? Does they sound familiar?
Yeah. Yes.
So see, if this is the frequency graph, right? First is frequency graph, the bar chart. So I have say below point. If I ask you a question that how many eggs are below 1.6 ounce, I'm weighing simple eggs. So how many eggs are below 1.6? So only how many eggs? Around only three eggs are below
Yes. Yes.
1.6. How many eggs are between 1.6 and 1.8? Can anybody answer that? How many
Two.
eggs are there between 1.6 and
One.
1.8?
No. 1.6. 1.6 and 1.8.
Yeah,
Two.
no. There are two bars, but each bar is representing a number, right? First
Yes.
bar between 1.6 and 1.7, it is around
20.
40. And 1.7 and 1.8, it is around 22. So 14 plus 22, like 36. Around 36 eggs are there between 1.6 and 1.8. So what I do, let us take a case of less than 1.6. So less than 1.6 means three eggs only. Total, if you total up y axis, it will be 140. Okay, so 3 divided by 140, that will be the probability. That will be the probability of getting a egg below 1.6 ounce. Okay, so we take every weight we take and calculate the probability in the same way. We'll get the right hand plot. So that is called something that is a bell curve. We call it a normal distribution. So egg is something natural phenomena. So many other natural phenomena tend to follow normal distribution. So that is a perfect bell curve. We call it a normal distribution. So these type of distributions are there generally. So many are there. So out of this, uniform, binomial, exponential, Poisson, student T, Gaussian, I squared. This we'll discuss in the class in this class in detail. Okay. So right now you should know that there are many kind of distributions possible. So this is the normal distribution curve which you see on the right hand side. It is a bell curve. So it is called normal distribution curve. Okay. So that is just one of the distributions. You can see the shape of different distributions. You can see the shape is also given. So chi squared is, you can see chi squared. Chi squared right hand tail is very long. And then well bull is a little weird actually. So like for log normal also you can see the shape. Student T distribution and Gaussian distribution shape is almost similar. Okay, so Gaussian distribution is applicable when we have number of samples more than 30. But if you don't have 30 samples, then you can use student T distribution. Okay. So these all we'll discuss in detail in one of our next classes. So this chart I had discussed. This chart I had discussed in yesterday's class. So if you joined new, I will share PPT once again. You can go through this chart. This is a very comprehensive chart on how to choose your distribution. Like there are so many distributions. You can read binomial. You can see discrete uniform, geometric, negative binomial, hypergeometric, uniform, triangular, normal, logistic, exponential, log normal, and minimum extreme. So there are some simple names I am giving, but there are many. And why don't discuss all these? If we discuss all these means, there will be a complete 300 books book on only this distribution. So we are not going in that detail. We'll be using some simple and common ones, commonly used ones. We'll be discussing like normal distribution, student T distribution, binomial distribution, Poisson, and exponential. So you can see their shapes. All this we will be discussing in our class in detail with formulas. Okay. So this is just chart I have given for completeness. So now I want to show you what is the difference between probability mass distribution and probability density distribution. Anybody? Can anybody just try from your school days or your college days? What is the difference between probability mass distribution and what is the probability mass function and probability density function? What is the difference? Anybody? If you don't remember, it's okay. We are going to learn it. Now you tell me, in my first class, I explained you the difference between discrete and continuous numbers. Can anybody repeat it? Difference between simple discrete, what is a discrete, what are discrete numbers and what are continuous numbers? So can anybody repeat from the recall from the first class?
So discrete is the number which is not changing. I mean, once that number is given, so like the product code or store code.
No, you're not. I'm telling functions. It will changing. It will change. It's a variable. It will change. But there is a distinct difference between districts and anybody.
So
Like
discrete numbers are whole numbers and continuous numbers are the ones with decimal that never end.
yes, that is the difference. See, if I say how many discrete numbers are between 1 and 10, you will say exactly 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly 10 numbers are there between 1 and 10. It is not less, it is not more. Exactly 10. Okay, so they are discrete numbers, whole numbers. Okay. Now I'll ask you how many numbers of continuous numbers, how many number of continuous numbers are there between 1 and 10? Anybody?
Infinite. I mean,
Infinite, right?
Yeah.
Because if I put decimal space 1.0, 1.01, 1.011, 1.012, 1.015, 2.0, 2.0111, 2.0234, 2 and then 3.0, something I can devise from point onwards, I can go to like say up to 20, 30 digits I can go. So you cannot count. So between 1 and 10, there are infinite continuous numbers. But there are discrete numbers are only 10, 1 to 10, discrete numbers. Okay. Sony, is it understood for you?
Yes.
You have to be loud and very talkative in this class, Sony. Just be more
Today
vocal
is my
and
first day in this class, so
don't worry, don't worry. All are your friends only. So don't worry.
yeah, I
All are
know.
we all are Indians, okay? And all are IT guys, so we have a common
we
identity.
they all are my ex-colleague.
Okay, so why you are worried? Yeah, we are just
No, I'm
be,
not worried. I'm not worried. I'm just
just be
like
very vocal and very outspoken in
I
this
am
class.
trying to understand what
Yes, yes,
what
very
you're
nice. Very nice.
just explaining and the things like you're presenting.
Sure, sure. I like it. Okay. Now,
Yeah.
suppose I take two coins. Now this, I'm talking about this slide. I'm taking two coins. Simple 1 rupee coin. Two coins I'm taking. So how much is my sample space out of this? Sample space I explained you. Now you might be remembering it. If I have two coins, what is my sample space? Sarthak?
Sir, uh, head, tail, uh, I mean, two coins together, right?
Two times together. I'm taking two coins together.
Yes,
How
sir.
much is my sample space?
Sir, four.
Four, right? Two heads and two tails.
Yes, sir.
Very nice. Okay. Now, I'm asking you probability of getting, like, what is the probability of getting no head? If I'm throwing those two coins together, I'm saying, like in two hands, take two coins I'm taking and throwing in the air. I'm asking you, what is the probability of getting no head? See, what are the cases? Head, tail, head, and tail, tail. Right? Only four cases are there, right? Either head can come, either head tail can come, and tail head can come, and tail can come. I'm asking you a simple question. What is the probability of getting no head? No head should be there. When my coins fall on the ground, I should not see head. I should see only tails. So how many? I should see tail on the both the. I should see tail on both the coins. So what is the probability?
25%.
Tell, yeah, it is there in front of you, right?
So 1/4.
Yeah, why 1/4? Because there are four cases: head, tail, head, tail, and tail, head. Only four cases are possible. Out of only one case is there of two head, two tails, tail, in which there is no head. So 1/4, right? What is the probability of getting one head? Only one head I want, not two heads, only one head.
So 2/4.
2/4, right? Why? I can get head, tail, first head, second tail, and then second head, tail, first head. Sorry, first head, second tail, and then first tail, second head. So HT and TH. These are the possibility where I can get only one head. So 2/4. Okay. What is the probability of getting two heads again? So two head is again 1/4. So now this is a distribution. We are talking about a distribution now, because we have a sample space of 4. Like as I Sarthak said, like you have if you have two coins, you have sample space of 4, like two heads and two tails. So that is what is your sample space. And out of that, you are drawing different probability. What probability? Probability of getting one head, probability of getting two head, probability of getting no head. Like that you are talking about different cases you are talking. So you can plot a graph, right? If I do a lot of these things, I can plot a graph. So see now here that the table. P is the probability of getting one head. Okay, so P is the probability. So X is equal to 0. X is equal to 0 means no head. That probability is 1/4. X equal to 1 means probability of getting one head is 1/2. Just now we saw 2/4 means 1/2. Probability of getting two heads is again 1/4. So 1/4. So if I tabulate like this, X is equal to 0, 1, 0 head, 1 head, and 2 head, what is the probability? It is represented X equal to X. X means your sample space, and out of x small is 1 by 4, 1 by 2 is 1 by 4. See, this is simple case. But if I take 10 coins together, I have 20, my head space, like my sample space will be 20, right? Because I have 20 heads and 20 tails. If I take 20 coins together, right? So in that case, if I plot, this graph will be very long. So this kind of distribution where we are dealing with discrete numbers, that is called probability mass function. So this is the probability mass function. At x equal to 0, P probability is 1 by 4. At x equal to 1, probability is 1 by 2. If x equal to 2, probability is 1 by 4. I can plot it, right? I can plot it. If I have more cases, 3 is very difficult to plot, but if I have more cases, I can plot it. So that is called probability function, probability mass function. So probability mass function means, like I want to show you here, like, yeah, probability density function. So generally, probability mass function, we don't plot them. We represent them in the form of a table. Generally, they are not plotted because they deal with discrete numbers. Okay. So this is the table. This table is a example of probability mass function because we are dealing with discrete numbers. Now, what is the like? So there are some properties of this probability mass function. If you add all the probabilities, 1 by 4 plus 1 by 4 plus 1 by 2, it will be 1. Right? 1 by 4 plus 1 by 4 plus 1 by 2. The number will be 1. Addition will be 1. So these are some if all the probabilities in the probability mass function, if you add up, they will add to 1. Okay. So like then, so it is denoted by that sigma fx. So like sigma fx, like sigma fx here is this 1 by 4, 1 by 2, 1 by 4. If I add up, then it will add up to 1. Okay. Now, here is the same question. So I'm taking another question now. Now, here, there is a numerical we are doing here. Just try to concentrate. There is a numerical we are doing here. Given a probability mass function fx. Probability mass function means there should be a light bulb inside your mind. Whenever I talk about mass function, means it's a discrete number. Okay. It is represented by a function fx equal to bx cube. So instead of populating a table, he has given a function to us. Like what? X is equal to 0. Like okay. So like we'll go ahead. Then for x equal to 1, 2, and 3. See, discrete number. So x can have only 3 values: 1, 2, and 3. That is given in the problem. Probability mass function is represented by fx equal to bx cube. Fx equal to bx cube. So at x equal to 1, what will be the value of probability mass function is called PMF. So I am asking you now a simple question. At x equal to 1, what will be the value of PMF? X can take only 3 values: x, 1, 2, and 3. So at PMF, what is the value at x equal to 1?
Sir, B.
Yes. X equal to 2.
Sir, 8B.
X equal to 3.
27B.
Yes, you got it. Okay. So now the values of probability mass functions at different x, you got the value B, 8B, and 27B. 1, 2, 3. Only 3 values are possible because it is given here that it can vary between only 1 and 3. Okay. Now he is asking find the value of B. The simple question is, in this fx, value of B is an unknown. He is asking you to find the value of B. So now what do you know? How you will find out? If you add up PMF at x equal to 1, x equal to 2, and x equal to 3, we saw here that sigma of fx equal to 1. It should add up to 1, right? So that we see here, see the symbol here. So sigma x belongs to S. X belongs to S means my S is my sample space. So x belonging to sample space, fx equal to 1. If I take all the sigma, it will be 1, add up to 1. So x is equal to, see now, see the second sigma statement. X equal to 1 to 3 sigma of x equal to 1 to 3, fx equal to 1. Now you just put the values. So b, like take out the b common, and then 1 cube plus 2 cube plus 3 cube equal to 1, because it is all, if I add up all the PMF, it should add up to 1. If I add up this, then it is 1 by 36. Is it not a simple problem? So here now we have understood the concept of what is a PMF. PMF, whenever PMF mass function comes, that means there should be a light bulb in your mind that it is dealing with only discrete values. X will be discrete. X cannot be 1.1, 1.2 like that. X will be 1, 2, 3, 4 like that. Okay. So we are dealing with discrete numbers. And all the PMF, all the X, if I take all the X 1, 2, 3, and I add up the PMF, it will be 1. Because that will be for total. So what is total sample space? X equal to 1, 2, 3. Only 3 possibilities are there. So if I add up all probabilities, it will total up to 1. Anybody challenge? Anybody having challenge? Amit bhai? Karthik? Any challenge in this problem?
No, sir.
We have to just find out the value of B. So we utilize one property of PMF, that for the entire sample space, if I add up PMF, it should add up to 1. That's what we know. So we have utilized that property. Let us go to next problem. The probability mass function table for a random variable X is given as follows. Okay, so generally like X equal to 0, 1, 2, 3, 4. So 4 values are possible, 0, 1, 2, 3, 4, X. Then we have to find the value of probability for every X. So when X equal to 0, probability is 0. At X equal to 1, it is 0.1. At X equal to 2, it is 0.2. X equal to 3, it is 0.3. At X equal to 4, it is 0.4. It is given, right? So now it is asking a simple question. What is the value of CDF, cumulative density function? Cumulative density function means, I'll explain you what is cumulative density. X less than equal to 2. So X should be either equal to 2, or it should be 1, or it should be 0. Means X should be less than equal to 2. What is the probability? That X should be either 0, 1, or 2. What is the probability? How will you find out? We have done this problem before. How you will do that? We have done this in our previous classes. X should be less than equal to 2.
Sir, we'll place the value of X in the function and calculate it.
There is
for
no function.
0,
It
1,
is function value is already given.
Yes, sir.
Values
Sir,
are already given. Then what? How will you calculate probability of X less than equal to 2? How you will calculate?
So we can add it for 0, 1, 2, or subtract 3 and 4 from.
Yes,
1.
exactly. You are right. So if you want X less than equal to 2 means X can be either 0, X can be either 1, or X can be either 2. So less than equal to 2 means you have to add 0, 0.1 and 0.2. So now what is the probability? 0.3. If I ask you same question, what is the probability of, so this is called cumulative probability. So we are adding up three probabilities here for X equal to 0, 1 and 2. It is called cumulative density function, because we are adding up, we are accumulating, we are adding up the numbers. So that is called cumulative density function. Now just try to find out what is the value of CDF Px less than equal to 4. What is the value?
Sir,
Less
1.
than equal to 4.
3 plus 2 plus 1.
Sir, 1.
How much total? How much it is totaling to?
सर 1 ही होना चाहिए क्योंकि पूरा सैंपल स्पेस कवर हो रहा है.
हाँ तो ठीक है, पर ये एड अप हो रहा है कि नहीं 1 पे?
So हो रहा है.
Yes, it is adding up to 1 now. So it is 1, right? Less than equal to 3, how much? Soni Singh, can you reply? X equal to X less than equal to 3. What is the value of CDF? If you don't understand, ask the question. Yeah. See, it is simple, right? So x can be either 0, 1, 2, or 3. Add up. 0, 0.1, 0.1, 0.2, 0.3, 0.6 is the answer, right? If you don't understand, ask the question. I'll appreciate you asking the question. Okay. So now we are getting to say these are discrete values, discrete probabilities. If I deal with continuous function means I cannot make table like this, because there are decimal points and there cannot be infinite values. So x-axis can be infinite values. I cannot make a table like this. So I represent it with a mathematical function. Okay. So when I deal with continuous number, then the same thing is called probability density function. See, so simple function I'm showing. It can be a normal distribution, it can be a triangular distribution, it can be log normal, it can be well bull, it can be beta, it can be uniform. So these are some very commonly used distributions which you can say. You go on increasing the value of x and calculate the probability. So x will be on the x-axis and probability on the y-axis and plot it. So you will get these kind of shapes. So there are some standard shapes which are called normal, triangular, log normal, well bull, beta, uniform. There are many more which I showed you here, right? I showed you here, right? See, you see here on the bottom, the green diagrams, the green charts, binomial, discrete, uniform, geometric, negative binomial, hypergeometric, uniform, triangular, normal, logistic, exponential, log normal, and minimum extreme. So these are mainly most of them are discrete functions. Okay, no, sorry, continuous distributions. So you got how we get a continuous distribution. So now let us do an example, then it will be more clear to you. Okay, so there are couple of see. Now I ask you a question here, like Sarthak will respond. What is the value of CDF? X greater than 1, but greater than or equal to 1, but less than or equal to 3. What is the probability? CDF, how much will be the function?
Sir, 0.9.
Huh?
0.9, sir. Sorry,
No?
0.6.
Yeah, 0.6. How you got it? See, if I ask you, what is the value of x,
X.
less
1 to 3, sir.
than equal to 3 and greater than equal to 2?
Greater than equal to 2 and less than equal to 3. So
3. So
5.
0.2 and 0.3, 0.5, right?
Yes, sir.
Similarly, if you want to find out the value of probability density function will not be represented by a chart like this. It will be always given by as a mathematical function. Okay, mathematical function means y is equal to x square, y is equal to bx square plus c, y is equal to bx4 plus x square plus c, like that. Some function will be given. That function will represent probability at different values of x. So how you want to calculate? See, suppose you want to calculate the probability between see the first expression, a less a less than x and x is less than equal to b. So it will be function at value, probability at value b and minus b minus fa. So you will calculate it with the help of integral calculus. So little bit of your 12th standard integral calculus will come here. So you will put fx here. Fx is your probability density function. You will put fx dx, integrate it between limits a and b. So it will be fb minus fa. Whatever integral value comes, so you have to first put b and then minus a, and then this is another thing here. See the last one. See the last one. First, probability mass function and probability density function value will be always represent more than 0. Why? Because probability density function and probability mass function, both represent value of probabilities, which lies between 0 and 1. So PMF and PDF both cannot be negative. Now here, we had seen that like here, you saw that, sigma you saw. Then sigma of complete, if you take complete sample space, sigma complete sample space fx equal to 1. So here it is sigma. Why it is sigma? Because they are discrete numbers. If they are continuous number, infinite number, same sigma changes to integral sign, right? Same sigma will change to integral sign. See, now here the last one you see, last bullet. Same sigma I am taking from minus infinity to plus infinity. Minus infinity to plus infinity I am integrating. In minus infinity is the value of x, not probability, okay? My x, for x varying between minus infinity to plus infinity. If I take the integral fx ds, that will be 1, because it will represent the entire area. Okay. So minus infinity to plus infinity fx dx will be equal to 1, because I'm covering. See how to calculate the probability. Like here you. So I'll explain a little bit. You just have a. If you're a little confused, in a couple of numerical examples, it will be more clear to you. See, so there are different probability density functions which are having standard formulas. I'm not taking you to just have a look. That's all. They are very complex formulas, right? There is a gamma notation. There is a like exponential notation, sigma and all. Like it looks very scary. We are not going to use them. We are going to use only continuous uniform distribution, which is 1 upon b minus a. Very simple formula. 1 upon b minus a. Only simple distribution formula we will use. All this formula are for your knowledge. You are not going to use them. We are not using, at least in our class. But you can see even gamma function there using student t distribution. The probability density function is having gamma in the denominator. So now let us take one example. Okay. So to make it clear, so if I take an example, let the probability density function. So whenever they say density function, there should be a light in your mind that it is dealing with continuous variable. My x is continuous. When they say probability mass function, that means a light bulb should immediately glow, and it should come to your mind that it is a x. My x is a discrete function. So here they are talking about probability density function, right? So x is continuous, infinite. It can have infinite. So is given by the function fx. Fx is nothing but your value of your probability. So fx is equal to p. It is given by c in the bracket 3x square plus 1. So p probability density function, which is called PDF. PDF will always be represented in the form of a mathematical function. So here mathematical function is very simple. One algebraic function is there, c 3x square plus 1. And now after that, we integrate we integrate it over minus infinity to plus infinity. The value is 1. Okay. So if nothing is given for limit, no limits, here limits are given. See, here limits are given where x varies between 0 and 2. Limit is given, na? 0 is less than equal to x and x is less than equal to 2. X varies between 0 and 2. But when there is no limits given, then we will integrate from minus infinity to plus infinity. What is infinity? Infinity is 1 by 0. But now here our minus infinity is 0 and here our plus infinity is 2, because for this problem x varies between 0 and 2. Both values possible. Between 0 and 2 only it is varying. Okay, now they are asking you find the value of c. Find the value of c. So this question is similar to this. This question is similar to this. So here, the function was given and it was a discrete function here, either mass function. F is equal to bx cube. X was taking only 3 values, 1, 2, and 3. And you are asked to find the value of b. So what you did, you just did the sigma, put value of x1, 2, 3, you got the value of b. The same problem is now repeated for, same problem is here, probability fx is bx cube. So their function is different. But similar problem is repeated for continuous functions. Okay. So now you see what to do. Now our formula is integration of minus infinity to plus infinity fx ds equal to 1. Fx dx equal to 1. So now here our minus infinity is 0 and plus infinity is 2 because it is given that x varies between only 0 and 2. So now we'll take a formula. See the second step. Integral of 0 to 2 c in the bracket, because that is our fx, right? Fx is what? C x 3x square, 3x square plus 1 dx equal to 1. Okay, now you can solve the simple integral. Like, see, if you take the integral, c will be common because c integral we can take common, c common. The integral of x square will be x cube by 3. Just little bit revise your integral, go home and try to find out from your 12th class. Integral of x square is x cube by 3. And integral of a constant, integral of 1 is x. So that's what is your 12th class 12th class integral and mathematics. So you have to little bit revise. So integral of x square is x cube by 3 and integral of 1 is x. So if you see the bracket now, the integral is solved. One time you put value of x, one time you put x cube as x, value of x as 2, and one time you put value of x as 3 and subtract them. You will get c10 equal to 1, c is equal to 1 by 10. So I'm not solving it because little bit integral with little bit limit, I think you should revise at home and try to find out how to solve them. Why am I teaching you this? Because this probability density function and probability mass functions are, if you go to some good company, they may ask you these as a part of your interview questions. So that's why you should understand a bit of what is PDF, what is PMF, how to calculate. Now I'm not teaching you the simple, so you just open your 12th class book or just find on the internet how to solve the integral with limits. So there are limit is lower limit is 0, upper limit is 2. Function is 3x square plus 1 dx. It's a standard integral. You just solve, you get the value of c as 10. Okay. So now next problem. Find the probability density function. Probability density function, again, it's for continuous numbers. Okay, continuous number. For continuous uniform distribution between interval 0 and 10. So it is given, it's a uniform distribution. Uniform distribution means it will be similar to like this. It will look like this. Similar. Uniform distribution means, see here uniform in the second row. Second row you see right hand side. Extreme. Third one. Second row, third one. Uniform very. So lower limit is A, upper limit is B. So between A and B, X varies between A and B. The probability is uniform. Probability is not changing. When X equal to A and X equal to B, I vary the value of X from A to B, any value. The probability remains constant. So that is what is your uniform distribution. Okay, so now you just put this value. So for uniform distribution, formula F, our value is very simple. Probability density function PDF is very simple. Fx is equal to 1 minus b by a. B is our upper limit and a is our lower limit. Okay. So x interval. So our lower limit is 20, upper limit is 40. So b is equal to 40 and a equal to 20. Just put it. Fx equal to 1 upon 40 minus 20 means equal to 0.05. Fx is a constant now. There is no x in that. Fx equal to 0.05. Now we know the integral. Now what we have to find out? Find the probability that x is less than 35. Find the probability that x is less than 35. So our PDF is 0.05 and our lower limit is 20 and upper limit is 35 because we have to find x is less than 35, right? So integral of lower limit 20, upper limit 35, 0.05 dx. So integral of 0.05 we can take out common, and if there is only one inside, so that is x. So that integral will be x. So now you take 35 minus 20, 35 minus 20 into 0.05, the value will be 0.75. Okay. So instead of in sigma in district PMF, there will be sigma because we are dealing with discrete values. And in the case of continuous PDF, there will be integral. So is this, I think you might have forgotten your integral calculus and all that. So even I don't blame you. Little bit you have to revise now. So this x, if you take the integral of 0.05 dx, 0.05 will be out, inside only 1 will be left. So integral of 1 is x, and lower limit is 20 and upper limit is 35. If you just keep it, you will get 0.75 the probability. Okay. So now we go ahead with one more simple function. The net weight of a certain packages follow the uniform distribution. Like there are some packets, maybe in a courier, in a similar packets are there, small packets of coming out of a factory, and it is given that they follow a uniform distribution. Between lower limit is 980 and upper limit is 1030. Lower limit, when there are n number of packets, there can be infinite packets. The lowest weighing is 980 grams and highest weighing is 1030. So our A is 980 and B is 1030. Our Fx is 1 upon B minus A. So 1 upon 1030 minus 980. Okay. So that is what is our Fx. So how much is that? 1 upon 1030 minus 980 means 1 upon 50. So 1 upon 50 is our
Fx.
PDF. When x varies between 980 and 1030, right? Now, what is the question? Find the probability that the net weight of package is less than 1 kg. Net than 1 kg means now our upper limit will be 1 kg means 1000 gram. So our integral will be 980 to 1000, 1 upon B minus A. B minus A means total limit 1030 minus 980 dx, and you keep the value, you will get the 0.4 probability. So here you have to bit apply of a little bit integral. So now you will feel the need of knowing simple integrals. You have to revise it. Okay, so don't worry if you are not understanding these problems. You can always see later. But you need simple integrals in solving PDF or PDF things. Now only a couple of concepts left here. See, I want to tell you what is joint probability distribution. Right now in PDF and PMF, PDF was continuous, PMF was discrete. We had only one variable x. So for a value of x, we are finding the probability. Now joint probability means now probability is depending on two variables, x and y. So now see, so I am making a, now in that case, you will get a simple table like this. Table like this means x is 1, 2, 3 and y is also 1, 2, 3. Next, I will show you what is the value. Now you want to see what is the probability when x equal to 3 and y equal to 2. Easy to read. Just read the 3 column and 2 column which is shown here. So it is given in the probability is given is 1 by 6. So example you got. So in this case now probability is dependent on two variables x and y. So what is the value of x? 3. What is the value of y? 2. So read the corresponding value. So that is the value of function of that is your joint probability function. So that is how you have to that is how joint probability is represented. Sometimes probability will depend on more than one variable, right? Right now we were discussing only one variable x. So here probability is very dependent on two variables x and y. That's why we are calling it joint probability. So in that case, you will get a table like this, two-dimension table. Okay. So I am not going beyond this. Then joint probability intersection, if you are finding, it is also PA into PB. The same formula is same. Joint probability A intersection B is PA into PB. And see now a simple example we'll do. What is the joint probability of rolling a dias rolling the number 5 in a fair 6-sided dice. A dice is there, pasa hai hamare paas. 6 numbers there, it is having 1 to 6. One face is 1, 2, 3, 4, 5, 6. 6 numbers are there, right? I throw it once, I get 5. By chance, I get 5. And second time I throw, again I get number 5. So like 2 5s I got, continuous 5s I got. So they are dependent on now. So what is that is joint probability. So now I'm asking you a question. Generally, if I throw a dice, I can get any number between 1 to 6. Okay. But now I'm throwing it 2 times and asking you the probability that continuously I should get 2 5s. So in the first dice, getting 5 probabilities 1 by 6, we know 1 by 6. 5 is only 1, success is only 1, and total outcomes are 6, so 1 by 6. And in second also, if you throw, getting 5 is 1 by 6. So individual probability are 1 by 6, 1 by 6. Now you want 5 and 5. 5 and 5 means it will be into. It will be into 5 and 5. If it is 5 or 5, 5 or 4, 5 or 3, then you have to add up. Now it is 5 and 5. End is there in between. So previously also, yesterday also, we discussed it a lot. So these both probability will be multiplied. 1 by 6 into 1 by 6. Total will be 2.8%. So these simple concepts we should understand for your interviews, and if you are looking for a career as a data scientist, this much of probability, basic probability, you should understand. Now, next question: what is the giant probability of getting head rolled by a tail? There is a coin, right? One coin, 2 times I am throwing. First I should get head, and then immediately followed I do one more experiment, I should get tail. Head and tail I should get. What is the probability? So problem is similar to this. In the first, if I throw, what is the probability of getting head? 1 by 2. Second time I throw, what is the probability of getting tail? 1 by 2. So I want head and tail. So you have to multiply. End means multiply, or means add up. So you have to multiply because I want first head and then tail. So head and tail 1 by 2, 1 by 2, 0.25%. Okay. So now here you don't have to do any problems on this. I'm not really asking you to do any problems on this. Just see the formula in the lower box. There are 2 variables. Joint probability means 2 variables, x and y. So your function will be like 5x square y, x square plus y square, x square y square plus xy. Like that, function will always involve 2 variables. So like that, you have to do 2 integrals this time. If this integral formula will be applicable, we previously what we said. You see this one, double integral, and previously what we said here. Here we said, yes, see here, the last bullet. We said single integral. Why single integral? Because variable is only x, only one. In case of joint probability, there are 2 variables. 2 variables. So double integral is there. fxy, integral dx dy, minus infinity to infinity. These problems are generally tough actually. If they give you any problem on joint probability, you should be able to evaluate double integral. So generally these problems are tough. So I'm not, I just taken one example for your just you see the example, like what is your fx here? Like PDF means probability density function. It is having 24xy. So it is having x also and y also. Function is 24xy. Both x and y vary between 0 and 1. It is given that, it is given here. X also 0 varies between 0 and 1, and y also varies between 0 and 1. Okay. So show that f so we have to prove that, show that f is the joint probability function for 2 random variable x and y. Now it is asking us to, like, for all the limits, you see, it is asking us to find out double integral. So you see the formula on the left hand side, double integral of fx comma y dx dy. Inside there is the identity given x plus y is equal to 1, x plus y is less than equal to 1. So you just convert it into x plus y equal to 1 and just place limit like that. X inside limit will be 0 and 1 minus y. You have to take this relation x plus y equal to 1. So x will be equal to 1 minus y. So inside keep that limit 0 and 1 minus y because it should satisfy this relation. So 0 to 1 minus y, outside y limit 0 to 1, 24xy dx dy. If you evaluate, you can show that the entire integral is 1. So that's what you have to prove. That if all for all the limits, if I this formula you have to prove here, this formula on the second one. Integral minus infinity to infinity, integral minus infinity to infinity, fxy dx dy equal to 1. That's what you have to prove here. So you keep all the values, you will get the value as 1. So you can show that it is 1. So I'm not explaining you. I don't think you are grasping all this. So with this, we have now, what is time? Okay, so our time is also over. So next is central limit theorem. It is very easy compared to, like, let me finish this problem also, like we are having 5 minutes. So let us finish this second joint probability problem. So if you are having interest, you can take it forward or you can just leave it. So instead of two variables, now we are having x and y, we are having x1 and x2, one and the same thing. So function given as fx1, x2 is 1 if x belongs to 0 and 1, x2 also belongs to 0 and 1. Okay, so between these limits, it is 1 and 0 otherwise. For our below 0 and above 0, it is always 0. And when x is there, x1 is there between 0 and 1, and x2 is there between 0 and 1, the value of fx2 is equal to 1. That's what is given. Okay. Now suppose we need like what the question is now. Question is, yeah. Now question is, when x1 equal to 1 by 2 and x2 equal to 1 by 2, what will be the probability? Now x1 value is also 1 by 2 means between 0 and 1. X2 value also between 0 and 1. Both x1. So our lower limit will be 0, upper limit will be 1 by 2. So keep in this integral actually. See this integral minus infinity to 1 by 2, inner integral 1 by 2, and outer integral also minus infinity to 1 by 2, fx1, x2, dx2, dx1. So now there is no function given, right? So if when x is between 0 and 1 by 0 and 1, fx is 1, right? It is given here. So we have put it here, limit 0 to 1 by 2, 0 to 1 by 2, dx to dx1, because the value of fx is 1. You just calculate it. First calculate the inner one and then calculate the outer one. You are getting the probability as 1 by 4. So here you should be able to solve double integral. So it's a simple problem, like if you are a little bit interested in maths, you can have it, like I explained you a little bit, but I cannot explain you how to evaluate a double integral. So that's the basic you have to find out from your class 12th integral. So if you are interested in this, you can see. Otherwise, just try to qualitatively understand what is the giant probability. So giant probability, here I explain you. It is dependent on two variables. And see how to read the table. Like if table is given, how to read it. X equal to 3, y equal to 2. You can easily read it. The value of probability will be 1 by 6. This is enough if you are not interested in integrals. But if you want little bits of maths and you are interested in little bit of integral and all, you can look at these problems, like this couple of problems which I have explained you here. Fx is given in terms of x and y, and here the constant value is given. So these two integrals you do, and any good company, like anybody, like if anybody, any interviewer is a circuit like me, and job is very high paying, I'll always give him this kind of integrals and small things. Just to check whether guy is having a good maths or not, because data science means all maths, all about maths. So they expect you to have some level of maths if you are doing a data science job. So if job is high paying, generally these kind of questions will be asked. But for like kind of Wipro, TCS, Infosys kind of jobs, these questions will not come. PDF, PMF, and joint probability and all that, they will not ask. But if you are preparing for GATE, or if you are giving companies like Google, Amazon, Adobe, they may ask this kind of questions. Okay. So like this is what the credit. I have like you can have a look at this. And now we have to, it's very simple. Now it is not tough. Tough part is over today. Next class is central limit theorem, which is a very basic theorem for all data scientists. It is told like that, like the people say that if you don't know central limit theorem, you are not a data scientist. If you are a data scientist, you know the central limit theorem. That is how it is. Okay. So this theorem is very simple concept, and it is related to normal distribution, and we will see it tomorrow. This so only few slides are left. So apart from that, I will take up some other topics. I'll start tomorrow. Okay.